Hey guys, welcome to Unit 3, Day 3. We're going to solve two-step equations. We're going to be doing some simplifying, which we know and love. Then we're going to translate some English to math, and we're going to solve the equations that we create. So if there's any questions that you might have, you can look in 2-3 in your book. You can practice. You can go to the textbooks online website and practice section 2-3, and you'll be really strong. All right, let's see what's going on. Okay. First thing I want to do, First thing I want to do is talk about how we solve equations in general. And the first question that we ask ourselves is, are both sides simplified? So if they're not, we have to go ahead and simplify them. So let's look. I've got my left side and my right side. Is my left side of the equation simplified? Is there anything else I can do? Are all my like terms combined? Are there any mathematical operations that PEMDAS tells me to do? Yes, there are. Looks like I've got to distribute that 5. So now on the right side, 15, that's already simplified. So what do I do if they're not simplified? Okay, I'm going to first leave change. I'm going to do my distributing, and then I'm going to combine my like terms. So become leave change. And let's distribute that 5. Yeah, I'm going to end up with 5x plus negative 30 equals 15. Let me see, is there anything else I can do on my left side? Nope, my terms are combined. My like terms are combined. It looks good. Okay, now the next question I'm going to ask myself is, remember, at this point it's simplified. I'm going to kind of be working backwards through PEMDAS. I'm going to handle my addition and subtraction stuff first. So I'm going to see if my variable term, this variable term right here with a variable in it, is all isolated, or is there a bunch of extra stuff done to it. And you can see there's a bunch of extra stuff done to it. Okay, you can see that I have my variable term, which is 5x, and we subtracted 30 from it. So I'm going to kind of work backwards. Remember, working backwards from negative 30, we'd have to add 30. So I'll add 30 to both sides. I'm going to write that again. You wouldn't have to because it would all be together on your sheet. I'm going to add 30 to both sides. And I'm going to get 5x, and this is plus 0, remember, because that's what I'm going for. I'm trying to get my constant on that variable side to be 0, is equal to 45. Okay. Now, my next question is, let's just check and see, is the variable term isolated? If it's not isolated, if there's a constant there, we're going to have to perform the inverse operation on that constant. Okay, this is the constant. And we're going to perform it to both sides. So the inverse operation of negative 30 or subtracting 30 is adding 30. Or just add the opposite. Okay, so now my next question is the variable isolated? Does it have a coefficient of 1? I want this coefficient to be 1 because if it is, then I'm just left with x, and that's what I'm looking for. But it's not 1, it's 5. So x is multiplied by 5. What's the inverse operation to multiplication? Division. Here we go. So I'm just going to rewrite it. You don't have to. It's probably all together on your page. If I'm multiplying x by 5, to get rid of that 5, I'm going to divide by 5. Remember, I'm doing that because my goal is to make that coefficient 1. And I end up with x is equal to 9. All right, I think that's good, but I'm going to check it because I have to. So to check my solution, I write my original equation. The original equation was 5 times x minus 6 equals 15. And I'm now going to plug in what I think the solution is. I think the solution is 9. So I have 5 times 9 minus 3 equals 15. Now PEMDAS tells me to do my parentheses first, and here I actually can do something. So 9 minus 3 is 6, so I end up with 5 times 6 equals... Hey, I wrote that wrong. Thinking ahead here. I end up with 5 times 3 is equal to 15. Let's keep it going. 15 is equal to 15. Yes, so yes it is. That checks out. And so therefore I box my solution. My solution is x equals 9. Okay. Let's try the next one. I'll try to go through it a lot faster. All right. Are both sides simplified? Yes, they're both simplified. There's nothing I can do to either side. So that's good. Is the variable term isolated? Is there a constant attached to it? Oh, yeah, there's a constant over there. So I'm going to get rid of that negative, that 1/9. So the opposite of adding 1/9 is subtracting 1/9. So I'm going to subtract 1/9 from this side. I'm going to subtract 1/9 from this side. Let's see what I end up with. So I want 7/9 minus 1/9 equals, I have a common denominator, so I can just subtract, is 6/9 equals, okay, and here my 2n, and my 1/9 plus negative 1/9 is 0. Looks good. Okay, now my next question is my variable isolated? Is the coefficient of this guy 1? Nope. So it's not 1, so it's multiplied by 2. So now I have to divide by 2. Okay. Now I have to divide by 2. So actually, let me write that. 6/9 divided by 2 over 1 equals, and this is going to cancel out, so I'll have n. All right, so what am I supposed to do? I'm dividing by a fraction. Flip the second and multiply. Okay. So I end up with 6 over 18 is equal to n, and that simplifies to 1/3 is equal to n. Let's check it and see. So I'm saying that 7/9 is equal to 2 times 1/3 plus 1/9. Okay, so I'm going to multiply first. 7/9 equals 2/3 plus 1/9. I just multiplied 2 over 1 times 1 over 3. Times 1 over 3. Now this, I'm going to have to get this into I have to make a common denominator so I can add those. So 7/9 equals 6/9 plus 1/9, because 2/3 is the same as 6/9. I'm going to multiply it by 3. 7/9 is 7/9. Oh, checks out. So my solution is n equals 1/3. Try that one again on your own. Seriously, guys. It's kind of interesting with the fractions. Okay. Next one is -2 times b plus 5 equals -6. Are both sides simplified? If this guy's not simplified, I've got to distribute. Is there anything to leave, chain, change? Whoops. I'm going to leave, chain, change, but I can distribute this -2. So I end up with -2b plus -10 equals -6. Okay. Now, so, we're going to handle our addition or subtraction. Okay, because I've got a constant on there, so I'm going to move that to the other side. Plus 10, and I get -2b equals -6 plus 10, 4. Does my variable have a coefficient of 1? No, it's -2. It's multiplied by -2. Let me divide by -2, divide by -2, and I end up with b is equal to -2, because 4 divided by -2 is -2. Let's try it and see if it checks out. So I said -2 times b, which I'm saying is -2, plus 5 equals -6. All right, PEMDAS tells me to do my parentheses first. -2 times, -2 plus 5, 3. Now I'm going to do my multiplication, -2 times 3. Would you look at that? Bam. Bam. Okay, so what my solution is, b equals -2. You might want to try that one again on your own. Okay, here we go. Are both sides simplified? No, I actually have to distribute this. What am I distributing here? I've got to distribute this negative. Who knows what number is in front of the parentheses? If there's nothing, then you better put a 1 on it. Okay, so now I'm going to distribute that negative 1 to everything inside. So I now have negative 1 times x is negative 1x, plus negative 1 times negative 10 is positive 10, equals 7. Okay? If you're not sure what to do, we can check. What do we? We leave change, then we distributed, and there are no like terms to combine, so we're good there. Okay, so now I'm ready to solve. Do I have a constant that I need to get rid of? I do. I've got to get rid of this 10. So I'm going to subtract 10 from both sides. Negative 1x is equal to negative 3. Now, is my x all by itself? Does it have a coefficient of 1? No. It's got a coefficient of negative 1. So what am I going to do since it's multiplied by negative 1? I'm going to divide by negative 1. Divide by negative 1. Okay, so I end up with x is equal to negative 3 divided by negative 1 is 3. This will get you every time. You have a coefficient of negative 1. You got to remember that you divide by negative 1. You have a negative in front of these polynomial in parentheses. You got to distribute that negative 1. A lot of things to remember in this problem. So I suggest you stop and you redo this problem again on your own. But let's check first. So now I'm saying that negative of 3 minus 10 equals 7. Okay, so what is 3 minus 10? I got to do this parentheses first. So the negative of negative 7 equals 7. Is that true? Is the negative of negative 7 7? Yes, it is. So my solution is correct. X equals 3. Okay. Let's keep going. Okay, we're going to talk about some word problems. So I'm going to read this one to you. Haley got a 60-cent raise after working at the Snack Shack for 3 months. She now earns $8.30 an hour. What did she earn before the raise? So what are we looking for? What are we looking for? The question's asking us what her salary was before the raise. So I think I'll call that, I'll say it's salary. And I think I'll call it S. Okay, that'll help us out. So now what changed about the situation here? Her salary changed. She was at one salary before, and then she got a 60-cent raise, and now her salary is $8.30. So what kind of change happened? I took her original salary, right? Her original salary, which actually I'll call S. Took her original salary, and I added what to it? I added 60 cents to it. And once we added 60 cents to her original salary, we got her new salary, which is $8.30. Yeah, I actually did that problem for you. Shoot. What kind of change happened? Her salary increased. Let me change that. Her salary increased. Got bigger. She got a raise. Okay. So do we know the original value or the new value? We actually know the new value, right? Her new value is $8.30. So what she had plus what her raise was now gives us $8.30. So how are we going to solve? Well, let's see. Is S isolated? No, it's not isolated. So I'm adding 60 to it. So I've got to subtract 60 cents from it. Subtract 60 cents from it, and we end up with S is equal to 13 minus 6 is 70. $7.70. So her original salary was $7.70. Let's check it out and see. So she got a 60-cent raise. Let's put 770 in my equations. Is 770 plus 60 equal to 830? Let's see. 770 plus 60 is $8.30. That equals to $8.30. Yes, it checks out. So it's true. Her original salary was $7.70. Okay, Luke finished the 5K race in 21.4 minutes. This was 1.8 minutes faster than his practice time. What's his practice time? Okay, so what's important here? Is the fact that it's a 5K important? No. But his race time, right, that's going to be important. Oops, let me make that line better. That's important, his current race time. And that's good. Oh, and he did even better this time than he did in practice. Okay, so what is changing? His running time, right? That's what's changing. That's the variable. We'll go ahead and call that T for time. Okay. Now, what kind of change happened? Because he started out with a race time of, I don't know what it was. And then he got 1.8 minutes faster. So what does that mean faster? Am I going to increase that time or decrease it? I'm going to decrease it. So his time decreased by how much? 1.8 minutes. Do we know the original value or his new value? Yeah, this is his new value. Okay, so let's write our equation. The new value is 21.4 minutes. And that's going to be the original value, which I don't know what that is, decreased by 1.8 minutes. So I'm trying to figure out what the original time was. So that means I'm going to have to add 1.8 to each side. And so this will be T on this side, T equals 0, equals, let's add 1.8 to each side. So 2, carry the 1, 3. So my original time was 23.2. Let's check it out. So I have my original time, 23.2, minus 1.8. That should be equal to, what is it, 21.4. Okay, let's do that subtraction. 12 minus 8 is 4. 2 minus 1 is 1. And 21.4. So I get 21.4 on this side, and I have 21.4 on that side. It checks out. So it's true. My time is 23.2 minutes. Okay, 2 more. The perimeter of a regular hexagon is 72.6 centimeters. How many sides does a hexagon have? 6. It's got 6 sides. The fact that it's regular means that all sides are the same length. Write and solve an equation to determine the length of each side of the hexagon. Okay, so what are we trying to find? We're trying to find the side length, right? Which I'm going to call S. What do we know? We know the perimeter, right? And I know that the perimeter is going to be equal to 6 times my side length. So I know my perimeter, and it's telling me my perimeter is 72.6. So 72.6 is equal to 6 times the side length. How do I leave S by itself? To divide by 6. I'm going to divide by 6. And I end up with, you can use a calculator if you like, 1, 2, 1, 12.1. 12.1 is equal to my side length. Let's test it and see. So 76 point, oh, excuse me. 72.6 is going to be equal to 6 times the side length. So 72.6 is going to be equal to 6 times 12.1. 72.6 is equal to, I'm going to just check this on my calculator right now. Turn it on. 6 times 12.1 equals 72.6 will all be. That checks out, so I can box my solution. My side length is 12.1. Alex mailed a package to Juneau, Alaska for $2.07. The first class rate was 23 cents per ounce. Write and solve an equation to determine the weight of the package. Okay, so what am I trying to find? The weight of the package. What should we call that variable? Let's call it W, shall we? Okay, so what do we know? I know the cost is $2.07, and it costs me 23 cents per ounce. So I'm trying to figure out how many ounces I have. So I know that $2.07 is going to be equal to 23 cents times the number of ounces, so I'll call that weight. Okay, 23 times the weight. What do I do to each side? I divide both sides by 23. 0.23. I'm going to do this one on my calculator. Okay, I have 2.07 divided by 0.23, and I end up with 9 is equal to W. That's pretty simple, nice and beautiful. Let's check it out. So my equation is $2.07 equals 0.23 times 9. I'm going to do 0.23 times 9, and that gives me $2.07. That checks out. So my weight in ounces is 9. Okay, my weight is 9 ounces. Okay, those were a lot of cool ideas. You're going to get to practice them in class. If you're still stumbling, I'd watch this again, work through these problems again, look in your book in section 2-3, and see you soon.